Hello everyone and welcome. Thank you for joining us from across the globe for today's session. We are living through an AI revolution, but as many of you have discovered, that revolution is hitting a significant roadblock. The industry is moving from the excitement phase to reality phase, and that reality is captured perfectly on our first slide, as you can see on screen. Garbage in, hallucinations out. We have all seen the headlines: AI model that provide confident but entirely incorrect answers. While many focus on the intelligence of the model, the real battle is won or lost in the data pipelines. The truth is, you cannot have a reliable AI without rigorous data engineering. Today, we are going to look at how we move beyond the hallucination hurdle by building the robust foundation necessary to make AI truly enterprise grade. Today, we will show how better data engineering is the missing link in a successful AI strategy. To provide some context on who is hosting you today, it is ACL Digital. Next slide, please. ACL Digital is an Alton Group company. We position ourselves as a trusted AI-led digital and system engineering partner. What makes us unique is our chip-to-cloud approach. We don't just look at the software layers. We understand the entire life cycle of a solution from the hardware and silicon level all the way up to complex cloud ecosystems. When we look at our collective strength with our parent company, Alton, the scale is truly global. We bring over 30 years of experience to the table, serving a diverse global customer base. We are powered by a global strength of over 57,000 professionals across the world. Alton is a $4 billion plus revenue company, providing the stability and resources needed for a massive digital transformations. With 35 plus design and delivery centers and 11 centers of excellence, we have the local presence to support global operations, including over 10 Fortune 100 customers. Finally, we know that in the fields like data engineering and AI, security and quality are non-negotiable. Our commitment to excellence is backed by a suite of industry standard certifications, including ISO 9001, AS 9100, and TISATs for automotive security, as well as CMMI Level 3 maturity. This ensures that when we talk about fixing AI, we are doing it within a framework of a world-class compliance and engineering discipline. Now, to take us through the technical strategies and the real-world application of fixing AI through data engineering, I'm pleased to introduce you our speakers. Next slide. First, we have Lakshmi Narayanji, the head of data, AI and Gen AI here at ACL Digital with us. Lakshmi is a distinguished strategic AI transformation leader who has truly impressive track record, specifically driving automation-led digital impact exceeding $20 million. Most recently, he spearheaded a Gen AI initiative that delivered $22 million in savings with a 40% faster turnaround time. Beyond the corporate world, Lakshmi is a recognized thought leader who advises prestigious organizations like ISRO and IIM, and he is also a TEDx speaker. Lakshmi, it's an honor to have you with us. Joining Lakshmi is Ramana Nagarajan, our data strategist. Ramana brings nearly 2 decades of deep-rooted expertise in data and analytics. He is a specialist in end-to-end enterprise data solutions, covering everything from architecture and engineering to critical pillars of governance and privacy. What makes Ramana's perspective so vital for today's topic is his focus on establishment data trust through rigorous quality and master data management. He has proven mastery of multi-cloud delivery across Azure, AWS, and GCP, and has a high impact outcome across staggering range of industries, from healthcare and BFSI, from telecom to retail. A few quick notes before we dive in. We encourage you to submit your questions through the Q&A panel. Throughout the presentation, we will reserve time at the end to address as many as possible. A link to the recording of this session will be sent to all the registrants. My name is Vishesh, and I'm handing over this mic now to our respected speakers. Lakshmi, over to you.
Thank you, Vishesh. Good evening and good morning, everyone. People who are connecting from the Western world. Thank you for joining us today for this important conversation on one of the biggest hidden risks in the enterprise AI world. Over the last 2 years, organizations worldwide have rushed into Gen AI implementations. I'm sure you have been hearing about Gen AI pretty a lot. Everyone wants Copilot, everyone wants automation, everyone's want AI-driven productivity improvement, isn't it? But very few organizations are asking the foundational question: is our data actually ready for the AI world? Is the data infrastructure ready for the next level of boom into the AI space? Here is the uncomfortable truth that we have been experiencing with our customers. Most AI failures today are not because of the model failures or the LLM failures. They are data failures, which are unfortunately disguised as AI implementation failures. So today's webinar, Ramana and me, we are going to discuss about the basic concepts, like why AI hallucinations happen, how our customers are facing it when they're implementing it, why even advanced LLMs fail confidently, and importantly, how poor data engineering is actually creating a business risk. And we'll also share with you how enterprises we are working with are systematically fixing it step by step. Remember, this is not a technology issue that we are talking about. We are talking about a governance issue, a trust issue, a business continuity issue when you think about implementing Gen AI. And I'm sure by the end of this webinar, I sincerely wish that everyone who is attending this will have a clear understanding that reliable AI begins long before the model training is happening. It begins with disciplined data engineering, which is the foundation for the entire AI space. With that context, I'll walk you through the agenda. So, Ramana, please move to the next slide. Yeah. So, this is what we are planning to cover today. We'll start with a simple but a powerful story about AI hallucination. And then we will actually break it down what hallucinations actually are. Because one thing we have learned by working with different customers is most of them have different definitions about hallucination, or on a lighter note, if I have to say, a lot of people are hallucinating about hallucinations. And what we have learned from our experience about hallucinations will help you understand that why models hallucinate, the role of the dirty data in this entire one, the real world enterprise failures, how they have failed, the financial impact of poor data quality, we'll talk about it in the AI space, and finally, practical enterprise solutions, because Ramana has an excellent demo also to show you at the end. So we also have a few live audience polls and a live demo towards the end. And this webinar is consciously designed to be very much practical. So at any point of time, if you have any questions, please use the Q&A forum and post across the questions. We will take it at the end. So moving on, let me start with a simple story for you. I want everyone to imagine this scenario. A customer contacts the insurance service provider, and the customer is asking whether a surgery claim is covered or not. And the AI assistant responds, your claim is approved. Your surgery on Mars is covered under Plan Delta 9, effective 1920. Sounds like a typical GPT generated language, isn't it? Now, obviously, this sounds ridiculous. But unfortunately, here is the dangerous part. The AI delivers the answer with total confidence. It does not make sense for the human who is reading it. Unfortunately, this is ridiculous enough for the people to understand that this is not true. Just imagine on the other side if the person sitting there does not understand the answer and believes that the answer is right. And this has happened with few airlines companies earlier. And a legal case, the customer has won because of the bot sitting on the other side giving some hallucinated answers. Now, the AI delivers this answer with total confidence, perfect grammar, professional tone, and zero hesitation. That is the real danger of hallucination. So, generative AI doesn't just make mistakes, it manufactures believable fiction, which you and me may not be able to distinguish. And especially in industries like airlines, the example that I was telling you, Just read about Air Canada, how they face this issue. Healthcare, banking, insurance, legal, public sector, take any industry for that matter. Because humans normally trust these systems confidently, isn't it? If GPT gives you an answer, you are most likely to believe it. Okay. And slowly over a period of time, we may lose trust, like how we don't trust Wikipedia as an official source of information. Over a period of time, we may realize that, okay, GPT may not be the best source of information. But as of today, LLMs are the best source of information. We all believe it, unfortunately. So the key insight that you need to have is the AI confidence is not AI correctness. That's something you should be aware of. And one of the biggest mindset shift that we need to have with enterprises today is never confuse fluency with truth. The underlying truth and the data that you might have may not give you the real picture. We have seen it in customer service pilots where AI confidently generated refund policies that never existed. In the banking space, we have seen co-pilots reference obsolete compliance rules, which may not even be relevant in today's context. So what data is getting picked up at the back end is more important when the answer is getting generated. It may be flowery English that is coming out, but actually coming from the wrong data. That is the risk. And these are operational realities in the enterprise implementations today. Moving on, let me slightly introduce what is hallucination. Let's understand hallucination a bit more. A lot of us think that hallucination is a wrong answer that is being generated. In fact, many times we think that LLM is generating a wrong output. Yes, definitely it's a factual error. It's confabulation, if you've heard of this term before in the Gen AI space, and the context shift. See, an AI hallucination is when the model generates fabricated, incorrect, misleading, or nonsensical output while sounding absolutely confident. But actually, these are generally three major forms. What is confabulation? That's a new word that you may be hearing today if you have not heard it earlier. The AI invents details that never existed in the first place. Like, for example, a sales co-pilot invents a new customer meeting note, which the customer did not even mention in the call. A legal assistant fabricating the precedents, like, oh, this Supreme Court judgment is related to this. It has never happened, but it is fabricating it. This is called confabulation. Factual error, you may know it. The model gives objectively incorrect information, wrong financial numbers, incorrect product specifications. It might be a result of factual errors. And context drift, as the name indicates, the model loses the original context over a period of time. For example, take the insurance claim context that we were discussing in the last slide. So AI suddenly starts discussing unrelated insurance claims, the holder policies and stuff. The context has drifted a lot, which the bot has not realized. So the most important thing for you as a practitioner to know is LLMs do not understand the truth. They predict statistically probable next words. They're good in predicting the next token. That's fundamentally different from reasoning. This is why, or this is where the data engineering matters more for you. Because the model's worldview comes entirely from the data that you're providing. Data plus a good large language model, that is English generation model, is what is the output that you're looking at when you are writing a prompt. So why do models hallucinate? Let's explore more. So moving on to the next slide. This is one of the important slides that you should understand because most people think AI systems behave like knowledge engines. Actually, they are not. They behave like probability engines. The model predicts what token is statistically most likely next. So that's the question the LLM is trying to answer. It is not actually answering the question what is factually true. You need to understand the fundamental difference here. As the famous saying goes, like Google gives the most popular answer than the right answer. Correct? That's the same case with the LLM too. And this distinction between predicting the next token versus predicting or factually giving you the right answer, this distinction changes everything. And this is the place where hallucinations happen precisely. So you need to look at the label noise. So if historically customer tickets were incorrectly tagged, the model also learns the wrong associations from the label. So the data is actually getting corrupted because of the wrong labeling that is happening there. A quality problem again. Class imbalance. If fraud data sets mostly contain normal transactions, the AI under detects rare fraud patterns. Again, class imbalance is again a data problem that comes in, which contributes to hallucination. Duplicate records. If one pattern appears repeatedly, the model overweights it. It gives more preference, more weightage to it. Again, it's a data problem. Missing values. I need not tell you if you're coming from the traditional BI, data engineering, and analytics background, you understand the problem of duplicate records and missing values. AI tries to fill gaps statistically, often inventing plausible but false information as part of the data set. And finally, bias corpus is always there. If hiring data historically favored certain profiles, AI recruiting systems inherit that bias, which is a very, very common problem in the issues that we have with the AI systems. And the temporal drift, a model that was created in 2022 compliance policies may not have the relevant answers, the right answers for a query in 2026. Obviously, it's going to give you outdated advice because it has got outdated data at the back end. So this is exactly why enterprises cannot treat Gen AI as merely an API integration exercise. Because people think that, okay, I'm using LLM, I'm calling an API, and I'm getting the output. That's not the case here. AI readiness is actually data readiness, governance readiness, architecture readiness, and observability readiness, which we will deep dive. So moving on, next slide. Now, this is something you need to understand. This summarizes the enterprise AI lifecycle failure pattern perfectly. The dirty data enters the pipeline. Nobody is fixing the real data problem there. The model gets trained on the dirty data. The model generalizes the incorrect patterns. The output sounds convincing, and humans start trusting the output that comes out of it. And business damage obviously follows because the entire organization is using this AI, which is running on the dirty data. So this is not actually a broken AI. It is a perfectly functioning AI trained on a broken enterprise reality. That is the problem. So I often tell my customers one thing: AI is more like a mirror. It reflects the organization's data maturity. If your enterprise data ecosystem is fragmented, if your data engineering pipelines are not perfect, your AI ecosystem will become fragmented too. So here I will hand it over to Ramana, who is going to take you through the different dimensions of the data quality and where exactly data engineering can build that strong golden layer of data foundation for you to have an excellent GenAI application on top of it. Over to you, Ramana.
Thank you, Lakshmi. Thanks for this. All right. So Lakshmi was explaining different problems with data. And we also wanted to understand if we can, at a high level group, they all fall under the data quality issues. Now we're going to talk about what are the dimensions of data qualities and data quality issues as well. That will eventually, if you don't fix it in your data pipeline, that will end up hallucinating when you train the model on top of it. So the first one is accuracy. For an instance, say in an electronic medical record, if somebody wants to register 180 lb as a weight, but they have incorrectly entered it as 180 kilograms. So obviously, this is an inaccuracy. So, inaccurate data is basically something misinterpreted and also misrecorded. And the second one is timeliness. Say it is about data freshness. If you don't have the right data at the right time, it is of meaningless. Think of you have the stock data that is coming every 15 minutes delayed. So your buying and selling predictions will go wrong. For an example, moving on to the next one, the completeness. If you don't have the data with the complete details, say for an example, if an organization sales team is actually filling up the lead form and it has all the details, but except the contact details. For this instance, say mobile number or the email addresses, you have all the lead details, but how will we contact them? So this is all about the completeness. And then the validity. So validity is basically about the format. Say you have a particular data to be in a particular syntax or particular format or should align with particular business logic. Like for an example, if you want to use date in a particular format, like month, date, and year, and if you want to validate an email address, you should have the @ symbol and the domain. And for any interest calculation. So these are all the validity, and it has to be up to the par. And then the consistency. So the consistency is basically about the same attribute. I mean, say for an example, if a banking domain is collecting data for a different product from the same customer. In my case, we can take my example. When I'm applying for any personal loan or housing loan, they are capturing my name as Ramana Nagarajan. But say, for example, on the other hand, if they are reaching out for another product, say cards, and they are capturing my name as Ramana N. The subject or the person are the same, but then the data is completely different, what they have captured at their end. I mean, so here we have no consistency of the same subject's data. So what will happen is we may not be able to create a customer 360 data, and we'll end up in duplicating the records for the same subject. And then the uniqueness. Uniqueness is basically you have duplicate records because of any of the other dimensions or any of the minor deviation with the other dimensions. So these are all the dimensions of data quality, and why this is important is if we don't have the data quality validations and data quality corrections as part of our data pipeline, then we will end up having chaos or garbage in our data lake or data warehouse. So before moving on to the next one, we can have a quick poll. What do you think about which dimensions of data quality you think is the biggest chaos or problem for your organization?
That's an easy question to answer, I'm sure. But let me look at the most popular opinion from everyone. While you answer, I would just like to add a point to what Ramana was mentioning in the previous slide. See, in the traditional BI world, the beauty is if there is wrong information, wrong data quality, it will come out in the report. And humans have a judgment to pass on top of the report. And it is easy for us to see a pattern there and find out that there is something wrong. But the problem in the AI space is the risk is exponentially high when it is packaged with a good flowery English, the wrong data. The data quality plus a great English, a confident answer makes people believe that the answer is right. That's the problem of data quality, poor data engineering in the AI space. Good. We are waiting for the responses for the poll. And we have got the response, I believe. Ramana, I think, as expected, the first option, accuracy and completeness, has got 50% votes there, polling there. And then 30% for consistency and 20% for timeliness. Uniqueness, nobody has selected it for a strange reason. But yeah, it's an expected lines to a greater extent. Accuracy is always a problem. Missing or incorrect facts. Many a times, lack of business context is what is creating the problem. Maybe as we progress, we'll share some of the examples from our experience. We will talk to you about it. Yeah, Ramana, back to you to continue. Yes.
Sure. So far we're talking about the AI hallucination and why it is hallucinating and what is the reason behind it and what are the different data quality parameters that is affecting the data quality and in turn the AI models. But why are we discussing all this in depth? Uh, the reason is we really have real-time chaos. To start with, there is an interesting case. One of the lawyers in US, for his argument, he started collecting the evidences or codes from ChatGPT, and apparently it ended up with a completely fabricated one by the ChatGPT. So it was quoted in CNN in May 2023. And the next one, it is in the medical field, and most of the medical errors might cause the fatal. So there is a medical survey and experiment happened with ASHP. So what happened is apparently they identified that uh, 3 of the 4 related questions or medical questions are being answered wrong by the ChatGPT or AI at that point in time. And the third one, this is an interesting one, the AI pricing chaos. Basically, the company wanted to implement an AI pricing model, which is based on, which is a dynamic pricing model. Now, apparently, because of the inconsistent data, they resulted in 60 million, downfall, and they apparently closed this entire program itself. And other interesting facts about the poor data quality, what the well-known organizations are coming up with their verdicts. So we have MIT, Informatica, IBM, Gartner. They are all having their own R&Ds, and these are the results. All right. So before we get on to the interesting part and very uh, you know uh, much needed part, which is solutioning, we just wanted to understand how your organization encountered the hallucination, whether you have come up or encountered any hallucination. If it is, how did you manage it? We can take a quick poll.
Just a second. We are triggering the right poll. Yeah. Please go ahead. Have you or your organization encountered an AI hallucination in your professional setting? We would like to know your opinion. While you answer this question, we'd like to share a bit of an interesting experience with one of our customers. For one of our customers, we developed a chatbot on top of the database of 25 tables. The chatbot was a simple one. They asked for an LLM-based, RAG-based chatbot, which is going to answer questions on the basic project management. So the end users are project managers and the PMO folks, the operations folks. They'll be asking questions about who is part of which project, what is the status of the project, how much has been the budget spent. So these are some of the questions that the end users might ask. So they wanted an LLM powered chatbot on top of the structured tables. This was the requirement from the customers. And ideally, this looks like a very simple requirement, right? And usually LLMs are very good when they sit on top of this unstructured data, that is the textual documents, policy documents, and everything. when they sit on top of the structured database, especially with around 25 tables, where each table has certain columns which have overlapping columns. Like, for example, how many consultants are there in a particular project? If this question has to be asked in the prompt, it has to fetch the answer from at least 2 or 3 tables together. A natural language has to be converted to a query SQL, and then it has to fetch the response. On a lighter note, what happened was every time this question was asked, the response was different. The customer was not very happy. And the team which was working with them thought that, oh, this is because of hallucinations, the answers are changing every time. But only when we started deep diving, we understood that the columns are similar across multiple tables. And when the natural language is getting converted to SQL query, so there was a bit of a confusion. The RAG, that is the augmented context that is being given to the LLM, did not have the right business context attached to it. So we had to feed in the right contextual data, what we saw as the drift earlier. We had to feed that contextual data precisely to the customer. And with that contextual data, the moment we fed it across, saying that this table has this column, and for these kind of queries, this particular table has to be fetched. And we started training the model with the right data, then the answer started coming out well. There was no problem with the LLM. The problem was with setting the right business context and giving the right data about every table to the LLM. So the data engineering and also a bit of creating a kind of a synergized tables, that is setting up a small data warehouse on top of 25 tables to aggregate the right ones so that the query can be generated in a perfect way. So these are all small changes that we did, which reduced the hallucinations to a greater extent. So what was perceived as an hallucination was actually a problem with a business context and a bit of a data engineering there. A small bit of experience which we wanted to share it across with you. Yeah, I think we can close the poll. Yes. So the results have come out. So 40% have voted for like yes, and it reached our end users and customers. Yes, that is seen. 30% have voted that yes, we caught it during testing. That's great actually. So that's the right way to do it. We have to do the testing in a significant way to ensure that we are capturing all these hallucinations. And 20% have mentioned they aren't actively using generative AI yet. Got it. Yes. Yeah, back to you, Ramana.
Thanks, Lakshmi. So in the next section, we're going to talk about how to solution around it. So we are bifurcating the solutioning in 2 parts. Number 1, what do we need to do at the data end? And the second one, how do we handle it while training and deploying the model itself? So to start with, let's talk about how to deal these data issues at the data side. It could be our data lakehouse, on-premise data sources, or any data warehouses. So the first step, we need to create a data profile. So how do we create it? We first need to understand what are the business metadata and what are the business glossaries along with the technical metadata. So we're going to come up with what are the business constraints, business logics, and the regular checks we're going to do, like nulls, timeliness, so on and so forth. With these details, we need to create an audit profile and we need to run it. So this is just test what are the issues we have and how many of them. And the next immediate action is we have to deal with these issues. So these all can be part of your ETL pipeline. Nowadays in modern cloud data platforms, you have their own data quality solutions, or you always have the script-based data quality solutions as well. And on top of it, we also have third-party data quality tools that we can always implement. But we have to implement or impose as part of our building data pipelines. So the cleansing and validation is an important point as the second action. But it is not stopping there, because we have completed the profiling and we have done the cleansing. And after cleansing, we have validated with or golden standard data. But on top of it, we have to keep monitoring what we have done at the audit part and as well as the cleansing and validation part. For that, we can handle this in 2-3 ways. Number one, we can create the dashboard, and as and when we can always see what is the data quality parameters or score against each of these dimension, and we can categorize this data into different segregations as well. That's number one. And number two, if we think the particular data issue is critical one or high one, we can also alert the CDO or the respective group so that they can take action. And also the last one, we can also send the periodical report to the respective group. Say, for an example, if you have data governance council or risk council, we can send the periodic data and they can prioritize accordingly. And what happens in a typical BFSI sector or healthcare sector, they segregate these identified risks into either the financial risk or the non-financial risk, and accordingly they will be segregated and prioritized accordingly. So these are the steps we need to take at the data side. Moving on, this is another very important thing, how we can deal this while we are developing the AI as such. So number one, data augmentation. So what does it mean is, we have to introduce a rigorous validation of the synthetic data. Why we are talking about synthetic data? Because most of the times when we develop the AI models, we may not be getting the sufficient data. We have to end up doing the synthetic data. So for that, we cannot fully rely on those data. So we have to introduce a rigorous validation, number one. And number two, the reinforcement learning from human feedback. What does it mean is, we have to have a human intervention in between so that we can ask the, what is the rank and what is the score for the particular data or particular the AI answer. These are all while training the AI model. And number three is RAG architecture. So in that, we're going to have the fact checking system. So, again, we cannot completely rely on what we are getting as a AI answer, because as we know, all the AI answers are statistically driven. So we need to have one more fact checking system during the training. And the last one is the curriculum learning. What does it mean is, without the synthetic data, we know we cannot train the model. However, we can split the training model into two phases. So in the first phase, let's have the absolutely accurate data. We call it as gold standard data. So we may most of the times get only limited of them, but let's first train the model with this absolutely data quality, high data quality data. This is phase one, so that our AI model will learn the basics, and it will understand the actual context. And then on top of it, we can train the models with the synthetic data with appropriate classes and bifurcations, or different groups of data. And of course, as we discussed, we have the other control parameters like fact checking and then the human in the middle and everything. So these are all the steps we can take while training the model. And the next step goes to deployment. So we have taken considerable steps at the training end, but that doesn't end there. We have to, continue, monitor, validations, everything after deployment as well. So as a first step, we need to understand, we need to validate, these AI outputs as well. We can do it in a couple of ways. Number one, we can have human in the loop. So before or without the human approval, we will not be giving the results produced by AI. Or we can also have automated quality control system developed in between the AI result generation and the displaying it to the end users. Number one. And second is the confidence threshold. We can always come up with a numerical percentage or numerical benchmark. Okay. Only then it is fit for the further cascading or display to the user. Say for an example, if it is a medical field, if the confidence score is less than 95 percentage, we may not be giving it to the end user or whoever is using to going to use the outcome. And the third one is the continuous evaluation. So even though we have all this set up and we have the high score, we need to keep evaluating the AI answers, because over the period of time, we get new data and we get new data sets, and we may lack of the new control system. So what does it mean is our data will slowly drift, and because of that, the context will slowly drift. So for that, we need to have a very controlled and high level evaluation system. And the last one is feedback loop. What does it mean is, so as and when there is an AI text produced, we're going to take a pass there, okay, and we'll try to get uh, the confidence from the end user themselves. For an example, if you generate something and you can always say, do you agree with this or not? So number one, we're going to get their answers. And if they say this is wrong, we can further ask, do you have a better answer or do you have a corrected answer? So we can get that as well. And it is not just getting the feedback, but we can actually record it in our training system, so that based on that, we can retrain the model and we can, uh, uh, optimize the model time and again. So that's what we wanted to cover as part of solution from the data side and as well as from the AI development side. So it's time for another and the last poll. So, which strategy you most likely to prioritize during the AI hallucination?
Yeah, I think we can continue here. Yeah, Ramna.
Yeah.
So we've got 44% voting for the first option, fixing our underlying data quality and governance. That's absolutely right. That should be the priority for us. And the next highest votes have gone for two options, 25% each, adding output validation fact checking layers. and utilizing human in the loop. Absolutely right. That should be our next priorities. Yeah, quickly moving on, Ramana. Just a quick time check. 14 minutes we have got, Ramana.
Sure, Lakshmi. Yes. All right. So we can quickly show a demo. And before that, just wanted to give you, the background about this particular demo video. What do we have? So it is just a subset of the product catalog of laptops and desktops. And we purposefully introduced the data quality issues. And if you notice here, we have negative values, we have null values, we have unacceptable values, and NaN values and everything. So number one, we wanted to understand how the AI model is hallucinating because of these data quality issues. And secondly, after fixing this, how we are getting the proper answers from AI. So let's begin with how the AI hallucinates with the data quality issues. So here, they're talking about, what laptops do you have in the staff? And, here what happened is, AI considers the negative value is a refund offer. And, because this is a clear hallucination, because as we discussed, AI doesn't understand or interpret the actual business context. As long as you have the bad data, we might have these kind of surprises.
Ravana, just would like to say your screen is stuck in live demo presentation.
Oh, I'm sorry for that. Give me a minute. Can you see this now?
Yes.
All right. I'll try to.
Ramana, if you can just explain this
Yes,
for everyone's understanding, that will be great.
yes, Lakshmi. So as we're discussing, we have intentionally introduced these data quality issues. And if you can see, these negative values of praise is misinterpreted by the AI model as a refund offer. So, this is a classic example of hallucination, especially the confabulation, because it misinterprets and it fabricates data, and it also fabricates the results. This is a classic example. And the second one is the price range accessories. And if you can see, some of the details has actually been, interpreted correctly. Like, I cannot definite it, and, availability is unclear. Even though we have data, just because of the attribute or complete details, it cannot give, the expected results. As a next step, we have created the data profiling in order to clean these data quality issues. And after that, this will be part of our ETL pipelines. And now for the same set of questions, the model behaves as expected with the appropriate answers. This is to reinstate that, as long as we feed up, quality data, we tend to get most of the right answers. If we know there is a problem with the data quality, and it is sure that we will be getting wrong answers, and that will mislead any business decisions, and what we call it as an hallucination. So that's pretty much all about this demo. So Lakshmi, I guess now we can open for the questions.
Yes, Ramana. Thank you very much for the demo. So now we are open for questions. We request you to put it across in the chat window. Maybe before we get to the questions, we'll just quickly summarize everything, the key takeaways, Ramana, if you can just move to the last slide.
Yes.
So in the last 55 minutes, we just wanted to cover 5 key messages from our experience. First one, hallucinations are symptoms. AI is only reflecting the enterprise data quality, which you should be aware of. Number 2, data quality has 6 dimensions. You cannot focus only on accuracy because that's the most popular word for any AI space. So please don't stick to that. There are 6 dimensions of quality that you should be aware of. The third one, cost is exponential. The poor AI damages the revenue, the trust, the compliance, and importantly, the reputation of your brand. That will take a hit if you don't have the right data engineering pipelines at the back end. That will result in poor AI output. Fourth one, solutions already exist. It's not like a problem that cannot be solved. We already have solutions. If you have a disciplined engineering as part of your the total software development life cycle, AI life cycle, then you'd be able to solve this problem. And that's where you need experts to assist you. And last but not least, governance is mandatory. Ungoverned AI eventually becomes the enterprise risk, which you should be aware of. Okay, so the next competitive advantage in AI is not going to come from who is going to adopt AI first. It will come from who operationalize the trustworthy AI at scale. So if you don't have the strong data foundation, as Ramana was saying, if you don't have the strong data engineering pipelines with great data quality, you are not going to build a trustworthy AI system in your organization. Okay, so I'd like to take a pause there and we will move on to questions. And yes, I'm just getting to the questions, Ramana. So we have got a first question from Jagadish. So what are your thoughts on introducing a semantic caching layer and a re-ranker lightweight model? Okay, that's a good question. Ramana, if you have any thoughts, you can add. Otherwise, I'll go ahead and answer this question.
Sure. So this is always, in modern technology stack, this is always advised. So we have to introduce the semantic model, as part of our data lake or the data warehouses. So this can be done in few ways. So I'm talking about from the data perspective. So number one, we can introduce with our data pipeline itself. Say for an example, if you are using a Databricks, you can always introduce your context, business logics, tags, everything in the pipeline itself, either via DDLs or via transformation scripts or via configurations. And this will eventually effortlessly use when you wanted to build AI ML on top of the existing data in your data lake. So that we have done actually for one of our manufacturing client as well.
Maybe I'll just quickly add on to that. Jagdish, that's a good question. So semantic caching layer, as well as the lightweight models that we're talking about, the re-ranker models, it has become part of the architectural decisions these days when we try to build the GenAI applications. So semantic cache will definitely help in improving the responses. It reduces the hallucinated response because it clearly identifies the similar vectors that are there. In fact, for one of the projects, when we developed a kind of a RAG application, we consciously used it to reduce the number of tokens, number one, and number two, also to ensure that the same question, when it is frequently asked again and again, we are giving the right answer with reduced hallucinations. So here we are actually, instead of rerunning the RAG, instead of requerying the vector database, instead of recalling the LLMs, which is very expensive, we generally give a previously validated enterprise approved response, which ensures that the hallucinations are reduced. So definitely, as you mentioned, this is one of the considerations that we maintain, no doubt. Now, coming to the lightweight re-ranker model, yes, most of the organizations, they stop at embeddings, vector search, and LLM generations. But when we work with the customers, we know that very well that bad retrieval means we are going to have hallucinated generation. So our job is to ensure that the right chunks of data are retrieved, and vector similarity alone will not help us. We need to ensure that we are getting the top K with the right re-ranking model. So to ensure that they are relevant, they are contextually strong, they are updated, and we use those models to reduce the hallucinations. So both these things are helping us out. In fact, lightweight ensures that the latency is also much better. So the performance of the models are great when it comes to these models. Yes. So lower latency, cheaper inference, these are all the benefits that we have seen when we work with the customers using these options. I hope that answers your question. Good. And there is one more question from Jagdish. Would you suggest increasing the context memory for agents to LSTM? So LTSM or LSTM you're talking about? Okay. So if you're talking about the long-term stateful memory architecture, yes. So I'll slightly put it this way. A controlled long-term memory is much, much better than unrestricted memory. Okay, because agents, when they start having this uncontrolled memory, obviously it might result in hallucinations on one side. And the reasoning also can become slightly stale over a period of time with the outdated data also sitting in the memory. That is another issue. And we have also seen some challenges with privacy risk when it comes to responding to capturing some of the data. Okay, and definitely regulatory compliance will come into picture when you're talking about the long memory. So keep this in mind when you're talking about long-term memory. This might result in these challenges. And last but not least, when the context window keeps on increasing, there is a very high chance that the contamination might happen. Your contextual contamination might happen there, which might result in problems. Okay, so you should ideally look for remembering the prior interactions with the help of a good memory, no doubt about it. You need to see patterns out of it. You need to retain the workflow context when you're designing agents there. And of course, to personalize responses, no doubt. So that's something you can do. Okay, so yeah, I hope that answers your question. Moving on, how does bad or poor quality data affect the answers generated by modern AI systems like ChatGPT or other generative AI models? Ramana, feel free to jump in if you have an answer. Otherwise, I can go ahead and answer this question.
Sure, I can join later.
Yep, sure. So normally, as Ramana was explaining during the webinar, every AI response is actually a reflection of the data that is sitting at the backend. Okay, the training data that is sitting at the back end. If your data has inaccuracy, bias, duplicate, inconsistency, everything that Ramana mentioned during the webinar, the AI is going to learn those patterns which are going to be highly invalid. Okay, this will directly result in hallucination, which is a factually wrong response, incorrect response, misleading communications. All these things are going to happen. That's exactly what we have covered in the last webinar. So that's going to happen, Partha. So we don't have a chance there. Okay. Good. So any other questions we have got? We have answered a couple of questions. We are on top of the hour. We can take one more question if there is anything. Otherwise, I'll hand it over back to Vishesh. I think we are on top of the hour. We would like to wrap it up on time to respect everyone's time. Yes, back to you, Vishesh.
Yeah, thank you, Lakshmi and Ramana. That was really insightful session. I think you have made it very clear today that AI might be the engine, but data engineering is the fuel. Moving from hallucinations to results requires exactly the kind of disciplined chip-to-cloud approach we discussed. Thank you both for sharing your expertise and for tackling those questions so thoroughly. Huge thank you to all our audience joining from USA, India, and all around the world. We appreciate you spending this part of your day with us. Your questions were excellent and really highlighted and the real world challenge organizations facing as they scale GenAI. So on behalf of ACL Digital and Alpen Group, we thank you again for being here and we look forward for seeing you at our next webinar. Have a wonderful day ahead. Take care. Bye-bye.
Thank you all. Take care. Bye-bye.
Thank you all.